March 9th, 1945. 14:20 hours. Technical Analysis Facility, 40 kilometers east of the Rhine River. The sound of metal scraping against concrete echoes through the cavernous warehouse as workers chain a captured American Sherman tank onto the examination platform. Major Klaus Hartmann, engineer graduated from the Technische Hochschule Berlin, approaches the vehicle with clipboard in hand. 37 impact marks scar its hull and turret. Dark scorch patterns radiate from each hit like frozen explosions. But the tank had fought for 3 consecutive days before capture. 72 hours of sustained combat. Hartmann circles slowly, his breath visible in the unheated facility. His eyes stop on an irregular weld line at the base of the turret, 83 centimeters long. The fusion pattern looks wrong, too inconsistent, too crude. He leans closer, running gloved fingers across the surface. The metallurgy doesn't match anything in his 14 years of arm. Ord vehicle experience. He orders immediate laboratory analysis. What Major Klaus Hartmann doesn't know, in 2 hours and 17 minutes, he will discover something that will make him sit down slowly at his desk, remove his glasses, and stare at nothing for 9 full minutes. He will discover that the Americans had repaired this 30-ton armored vehicle with a household clothing iron. And in that discovery, he will understand with mathematical certainty that Germany has already lost the way CK at an oblique angle 3 days prior. The shell failed to penetrate, but fractured the armor plate. Morrison stands in the barn doorway, watching his crew chief, Sergeant William Chen, examine the damage. 23 Sherman tanks in the battalion, 17 operational, 6 awaiting repair. Nearest proper maintenance depot, 214 kilometers west. Morrison needs this tank combat ready in 48 hours. Division is pushing east. Every operational vehicle matters. Chen Lo alks up from the crack, his face grim in the weak January light. Sir, this needs foundry work, proper welding equipment. We've got a portable torch, but it won't generate sufficient heat for armor-grade steel. Morrison asks what they do have. Chen inventories. 1 portable acetylene torch with limited fuel, 1 gasoline-powered generator producing insufficient amperage for military welding equipment, various hand tools, and determination. What Chen doesn't mention yet, in the abandoned farmhouse. Next door, he'd found a Sunbeam clothing iron, model 1938, still plugged into a wall socket, left behind when the family fled. That iron, and an idea that violates every principle of metallurgical engineering, will keep Thunderbolt 3 in combat for 3 more days. Electrical heating elements. The fusion pattern indicates sustained pressure application rather than traditional torch welding. The temperature distribution suggests approximately 420 degrees Celsius, applied over extended duration, far below the 1,200 degrees typically required for armor-grade steel fusion. Yet molecular bonding analysis confirms genuine metallurgical fusion at the weld site. Hartmann calls in Oberleutnant Friedrich Weber, the facility's Seno, IOR metallurgist. Weber examines the sample under electron microscopy. He looks up 15 minutes later, confusion evident on his face. Major, this is impossible by conventional theory, but the evidence is irrefutable. Someone used a low-temperature, high-pressure method with sustained heat application. The thermal signature matches household electrical resistance heating. Hartmann asks Weber to be specific. Weber sets down his instruments. Sir, they repaired this tank with something like a clothing iron. Silence fills the laboratory. Outside, the distant sound of artillery rumbles from the west. The Americans advancing. Always advancing. Hartmann orders a complete forensic examination of the entire vehicle. Every repair. Every modification. He needs to understand not just how this was done, but what it means. -7 degrees Celsius. He'd studied the crack for 2 hours, running calculations in his head. Traditional welding would require equipment they didn't possess. The armor was 51 millimeters thick at this point. Chrome molybdenum steel, designed to withstand high-velocity impacts. The crack penetrated 41 millimeters deep. Critical structural compromise. Morrison needed this tank operational. Chen thought about his father's machine shop in San Francisco. The principle of metal. Urgical fusion. Sufficient heat plus pressure plus time equals molecular bonding. Variables could be adjusted. Lower temperature meant longer duration and higher pressure. He retrieved the Sunbeam iron from the farmhouse. 2 kilograms. Electrical resistance heating element. Maximum temperature. Approximately 430 degrees Celsius when supplied with proper voltage. The generator could handle that. Chen found fragments of destroyed German armor plating in the barn's corner. Anal. YZ the metal composition by eye and experience. Similar enough to the Sherman's armor. He ground the fragments into a powder using a bench grinder, mixed it with iron filings from the maintenance kit, created a crude welding compound. He heated the iron for 47 minutes until the base plate glowed dull orange. Then began the process that would take 6 hours and 43 minutes of sustained, precise application. Forensic team documents 17 distinct repair modifications on the captured Sherman. The turret weld using the thermal signature consistent with household electrical heating. The track tension adjustment made with modified agricultural tools. The engine air filter rebuilt using material from a civilian automobile. The ammunition rack reinforcement using wood from barn planks. The periscope lens replaced with glass from a civilian vehicle. Each repair represents field improvisation that should don't work according to German military doctrine. Each repair had worked well enough to keep the tank operational for extended combat. Hartmann spreads reconnaissance photographs across his desk. Intelligence reports from the previous 6 weeks. Pattern recognition from 14 years of engineering training. If one American tank was repaired with this level of improvisation, how many others? He requests all reports of captured or destroyed American armored vehicles from the past 3 months. E-files arrive in 2 hours. Hartmann and Weber work through the night. They find evidence of similar improvised repairs on 23 additional Sherman tanks. Welding patterns inconsistent with military equipment. Modification signatures suggesting field mechanics working with whatever materials were available. One tank had its transmission housing reinforced with steel from a destroyed German half-track. Another had its turret ring realigned using a hydraulic jack from a French farm tractor. The pattern becomes undeniable. The Americans weren't just repairing vehicles. They were maintaining combat readiness through systematic improvisation at every level. E of the armor steel began accepting the compound. Microscopic fusion occurring at temperatures far below traditional welding standards. The laws of metallurgy weren't being broken. They were being exploited through a method that no German engineering manual would ever consider. Morrison watched for 3 hours before leaving Chen to work. The sergeant barely spoke. Total concentration. His hands steady despite the cold. The iron's electrical cord stretched across the barn floor to the generator. The barn smelled of hot metal and acetylene residue. By 1400 hours, Chen had completed the primary weld. He tested it by striking the surface with a hammer. The weld held. He applied a secondary layer. Reinforcement. By 1830 hours, the crack was sealed. Chen stepped back, exhausted. Morrison examined the repair in the fading light. The weld looked crude, irregular, nothing like proper military maintenance. He asked Chen if it would hold in combat. Chen replied, "Sir, it violates everything I learned in technical school. But molecular fusion doesn't care about textbooks. It should hold. Maybe 3 days. Maybe 3 hours. Only way to know is field test." Morrison made the decision. Thunderbolt 3 would return to combat the following morning. KS repaired with improvised methods. All functional. All returned to combat. He pulls out his own files. German armored vehicle maintenance records from the past 6 months. 743 Tiger tanks constructed. Technical superiority unquestioned. 88mm main gun. Armor up to 120mm thick. Engineering masterpiece. But operational rate, 14.5%. 108 Tigers currently combat ready across all fronts. The rest await parts. Await specialized repairs. Await transportation to rear area maintenance facilities that are increasingly distant from collapsing front lines. The Krupp factory equipment, 15-ton precision welding machines, sit idle in facilities without electrical power. Specialized technicians scattered or dead. Supply chains severed by Allied bombing. Bureaucratic procedures requiring 17 signatures for non-standard repairs. Meanwhile, an American sergeant repairs a Sherman TA, NK in a Belgian barn using a household clothing iron, and the tank fights for 3 more days. Hartmann begins writing his report. His hand trembles slightly, not from cold, from recognition. He is documenting the moment he understood Germany has already lost. IVE, support infantry advance toward the German border, 8 kilometers southeast. The crew knows about the improvised repair. Loader Corporal David Anderson had asked Chen directly, "Sarge, we really going into combat with an iron-fixed turret?" Chen had replied, "We're going into combat with molecular fusion that'll hold or fail based on physics, not opinions." The Sherman advances with 3 other tanks from the company. Scattered resistance. German forces retreating but contesting every kill. Meter. At 11:20 hours, first contact. German position on a wooded ridgeline. Return fire. A 75mm round from a Panzer IV strikes Thunderbolt III's turret. Not direct hit. Glancing impact on the right side, 22 centimeters from Chen's weld. The turret rings like a bell. Smoke. Morrison checks internal integrity. No penetration. No casualties. He rotates the turret. The weld joint holds. Chen's repair, made with a Sunbeam household iron and ground-up German air. More fragments has just survived its first combat test. Anderson whistles low. Holy hell, it held. Morrison orders continued advance. The Sherman fires 3 rounds at the German position. The recoil stresses every joint and weld in the vehicle's structure. Chen's repair doesn't fail. By nightfall, Thunderbolt III has engaged enemy forces 7 times. The weld has taken stress from 4 nearby impacts and constant vehicle movement over rough terrain. It holds. EDID at 0700 hours March 10th contains 23 pages of technical analysis and 6 pages of strategic assessment. The technical section documents the improvised repairs in precise detail. Photographs, metallurgical analysis, comparison with German maintenance protocols. The strategic assessment is devastating. Hartmann writes, the capacity to repair armored vehicles using household electrical appliances represents not technical ingenuity alone, but systematic superiority of organizational doctrine. American field mechanics possess authority to improvise solutions without awaiting approval from distant command structures. German maintenance protocols require specialized equipment and formal authorization for non-standard procedures. In theater conditions where supply chains have collapsed and command structures are fragmented, the American system maintains operational readiness, while the German system achieves technical perfection on vehicles that never return to CI. Ombat. He continues. The Sherman tank repaired with a clothing iron fought for 72 consecutive hours after repair. Current German operational rates show average Tiger tank availability of 14.5%, despite technical superiority. This discrepancy represents the material difference between losing and winning independent of battlefield courage or tactical skill. Hartmann signs the report. He knows where it will go. Up the chain of command. To officers who will read it, file it, and continue ordering troops to hold positions with tanks that cannot be repaired, because proper equipment is 200 kilometers away, and authorization requires 3 weeks. He understands this report will change nothing, but he also understands he has documented the moment when German technical superiority became operationally irrelevant. About it during morning maintenance. We're riding a tank held together by a Sunbeam iron. My grandmother had the same model. Chen doesn't laugh. He inspects the weld every morning, looking for stress fractures, signs of failure. The molecular fusion holds. Day 2 of combat operations brings heavier engagement. German counterattack at 14:30 hours. 3 Panzer IV tanks supported by infantry. Thunderbolt III takes position behind a stone wall. Morrison identifies targets. Gunny. R fires. Recoil rocks the vehicle. The weld joint flexes but holds. A German round strikes the Sherman's front glacis plate. 39 degrees angle. The shell ricochets. Fragments pepper the turret. 1 fragment hits 2 centimeters from Chen's weld. The repair holds. 5 hours of sustained engagement. 16 rounds fired from the main gun. Each shot producing recoil stress measured in thousands of kilograms of force. The weld, made with a household iron and improvised compound, continues performing structural duty equivalent to factory-grade armor plate. That evening, a lieutenant from Battalion Maintenance visits Thunderbolt III. He wants to see the repair everyone is talking about. Chen shows him the weld. The lieutenant runs his hand across it. This shouldn't work, Sergeant. Chen replies, Sir, it doesn't care what it should do. It cares what it does. The lieutenant photographs the weld, takes notes. He tells Chen that battalion wants to document this for training purposes. Field expedient repairs, making do with available resources. Chen asks if they want the iron too. The lieutenant says yes. Preserve it for the museum they'll build after the war. Chen nods. He'd already planned to keep it, with maps showing contracting German positions. 3 other officers present. Hartmann presents his findings. Technical details. Photographs of the weld. Laboratory analysis confirming household electrical thermal signature. Strategic implications. Steiner listens without interruption. When Hartmann finishes, silence fills the room for 43 seconds. Then Steiner speaks. Major, You are telling me that American mechanics repair tanks in barns, while our tigers sit immobile awaiting factory equipment that will never arrive? Hartman replies, Yes, Herr Oberst. That is precisely the situation. Another officer, Hauptmann Rudolf Klein, objects. This is one tank, an anomaly. It proves nothing about systemic differences. Hartman had anticipated this. He presents the additional 23 cases, the pattern of improvised repairs across multiple American units, the operational readiness statistics, the contrast with German maintenance paralysis. Klein falls silent. Steiner studies the photographs for 4 minutes. Then he asks the question Hartman knew was coming. Can we implement similar field repair authorization for our forces? Hartman provides the answer he'd rehearsed. Herr Oberst, the issue is not technical knowledge. German engineers are excellently trained. The issue is systemic. Our doctrine requires specialized equipment and formal authorization. Changing this requires restructuring command philosophy across the entire Wehrmacht. The Americans built this capability into their system from the beginning. We are attempting to modify our system while retreating under fire. It is too late. At the edges of the repair, Chen reports to Morrison, Sir, the weld is starting to show fatigue. It's exceeded my expectations, but physics doesn't negotiate. I estimate 6 to 12 more hours before structural integrity becomes questionable. Morrison radios battalion. Informs them, Thunderbolt 3 needs to rotate out of line for proper maintenance depot repair. Battalion acknowledges. But before the Sherman can withdraw, German forces launch local counterattack at 10:15 hours. 4p. Anthers supported by infantry. Heavy engagement. Thunderbolt 3 and 2 other Shermans form defensive position. Morrison knows the weld is compromised, knows each shot from the main gun risks catastrophic failure. But the infantry needs armored support. He orders engagement. The Sherman fires 9 rounds over 47 minutes. An 88mm round from a Panther strikes Thunderbolt 3's turret at 11:23 hours. Direct hit. The shell penetrates partially through T. Turret side armor, 7 centimeters from Chen's weld. The impact should have should have killed the crew, but the weld joint, weakened and beginning to fail, absorbs and redistributes the force of the impact in a way solid armor plate wouldn't have. The imperfections in Chen's improvised repair create a structure that flexes instead of shattering. The shell penetrates but loses sufficient energy that it fails to detonate. Thunderbolt 3 is disabled, but the crew survives. All 5 men evacuate safely. Chen looks back at his weld as they withdraw. The repair has finally failed, but it failed in a way that saved their lives. Report articulates with mathematical precision what we have known intuitively for months. We possess superior tanks that cannot fight because they cannot be repaired. The enemy possesses inferior tanks that continue fighting because they can be repaired anywhere, with anything. This is the war in microcosm. But Balk's note changes nothing. The structural problems Hartman identified cannot be solved by recognition. German forces continue retreating. Tigers sit immobile awaiting parts. America, in Shermans, some repaired with methods that violate engineering textbooks, continue advancing. On March 19th, Allied forces cross the Rhine. On April 2nd, the technical analysis facility where Hartman examined the Sherman is evacuated. Hartman packs his files, including all documentation of the clothing iron repair. He doesn't know if anyone will ever read them. He knows he has documented something important. The moment when a household appliance proved more strategically valuable, the Anna Krupp precision welding machine. The moment when improvisation defeated sophistication. The moment when the war's outcome became undeniable through metallurgical analysis of a crude weld in a barn. Pre-minute application process. The investigator asks if Chen knew the repair would work. Chen replies honestly, No, sir. I knew the theory was sound. Molecular fusion under sustained heat and pressure. But I'd never attempted it on armor-grade steel with household equipment. It was educated desperation. The investigator asks if Chen still has the iron. Chen had saved it. Stored it carefully after the Sherman was disabled. He produces it from his barracks locker. Sunbeam model 1930. 8. Cord melted. Baseplate discolored from sustained high heat. The investigator photographs it from 6 angles. Takes detailed notes. He tells Chen this iron will be preserved in the Army archives as an example of American ingenuity and adaptability in field conditions. Chen asks what happened to the Sherman. The investigator explains. Thunderbolt 3 was recovered after combat. Sent to technical evaluation. Engineers examined Chen's weld extensively. They were fascinated by how the Effect repair had actually created superior impact absorption characteristics. The metallurgical imperfections distributed force in ways uniform armor couldn't match. It was accidental superiority through improvisation. The Sherman is being preserved for eventual museum display. The iron will be displayed alongside it. Documentation of German armored vehicle maintenance problems is thorough. They ask about his reports. Hartmann provides copies. The British investigators are particularly interested in his analysis of the Sherman repaired with the clothing iron. They ask why he wrote such a detailed report about one captured tank. Hartmann explains, "I wrote it because that single repair represented everything wrong with our system, and everything effective about yours. We had the finest tanks in the world sitting, immobile because we couldn't improvise repairs. You had inferior tanks that kept fighting because your men were authorized to solve problems with whatever resources were available. The clothing iron wasn't significant because it worked. It was significant because your system permitted a sergeant to attempt it without requesting permission from officers 300 kilometers away." The British interviewer asks if Hartmann believes this was decisive to the war's outcome. Hartmann considers carefully before answering. The war was lost for many reasons: industrial capacity, resource access, strategic errors. But the clothing iron repair exemplified the systemic difference that made those larger factors decisive. Your mechanics repaired tanks in barns. Our mechanics awaited factory equipment that never arrived. Multiply that difference across thousands of vehicles and millions of decisions. And yes, it was decisive. The interviewer asks if Hartmann would have changed German doctrine if he had authority. Hartmann replies, "By the time I wrote that report, it was too late to change anything. The question isn't what I would have changed. The question is what we failed to build into our system from the beginning." Odell, 1938. Cord melted. Baseplate permanently discolored. The informational placard reads, "In January 1945, Sergeant William Chen repaired critical turret damage on this Sherman tank using this household clothing iron. The improvised repair held for 72 hours of combat operations. This exemplifies American military adaptability and field ingenuity during World War II. Visitors photograph the iron. Some smile at the absurdity. A 30-ton armored vehicle, repaired with a household appliance. Others understand the deeper significance. A tour guide explains to a school group, "The iron represents something more important than one repair. It represents a military system that empowered individual soldiers to solve problems creatively without awaiting permission from distant commanders. That decentralized decision-making authority was a strategic advantage as important as industrial production." An elderly man stands before the display for 7 Yansai Newts without moving. His name tag identifies him as a museum volunteer, Korean War veteran. He'd served in an armored unit. He understands what the iron represents, not the specific repair, the philosophy. Trust your people, give them authority. Accept imperfect solutions that work over perfect solutions that never arrive. He's seen modern militaries forget these lessons. Become bureaucratic. Require authorization for decisions that should be made instantly by the people closest to the problem. The iron reminds him that the best system isn't the most sophisticated, it's the most adaptable. The capacity for field repair using improvised methods represents systematic superiority, not merely technical ingenuity. Organizations that empower individuals to solve problems creatively will maintain operational effectiveness under conditions where rigid systems collapse. The American sergeant who repaired armored vehicle with household appliance possessed authority our engineers lacked despite superior training. This authority differential, multiplied across thousands of decisions, determine operational outcomes independent of equipment quality. The report is taught at some military academies as a case study in organizational design. The question posed to officer candidates: your forces possess technically superior equipment, but inflexible maintenance doctrine. Enemy forces possess inferior equipment, but adaptable maintenance authority. Which system wins extended conflict? The correct answer is obvious in retrospect. It wasn't obvious to German command in 1945. The clothing iron had proved it mathematically. One crude weld in a Belgian barn, holding for 3 days of combat, demonstrated that adaptability defeats sophistication when systems collapse under real-world stress. The lesson remains relevant. Rigid organizations still build impressive systems that fail under pressure. Flexible organizations still empower individuals to improvise solutions with whatever resources are available. The iron sits in its museum case, a small household appliance that documented the moment when engineering excellence became operationally irrelevant and desperate improvisation became strategic victory.